Hello, I'm going to be presenting my experiential learning phase one for my internship, even semester, first year. My name is Akash C. Modalgiri, and here are my student details. I completed my internship through Internshala on data structures and algorithms. So we'll go through the table of contents as we go through the PPT. And here are my test scores, which were conducted by Internshala. And I was mentored by Mr. Anand Mahajan, who has been mentoring students for over 20 years and who runs a training institute called Mahajan Computers and who has worked with IT giants like AppTech and NIIT. So the course overview, this is the course overview in Internshala. We had to go and we'll go through uh, each learnings from each course as we progress through the slides. Firstly, efficient way to write algorithms. Um, Mr. Mahajan taught us how to write algorithms efficiently, and here's an example or a screenshot from his presentation on how to write matrix multiplication algorithms. Uh, we also learned that algorithm is a very essential tool uh, made to before programming. With the help of algorithms and basic understanding of coding languages, you can translate an algorithm into any code, maybe C, C++, Java, etc. We we basically learned the implementation of various data structures through C program. And firstly, uh, Sir took us through pointers, single and double dimensional arrays, and some basics in searching and sorting, binary search, linear search, bubble sort, etc. And later we went through each data structure in brief. Then we went into the implementation through C. First data structure we covered was stacks. Stacks follows last in first out principle, and here are some stack informations. Uh, Stack is also used in generating an output of a function. It's used in job execution in internal memory. There are various functions in stack such as push, pop, seek, add, is empty, is full. Push is to push an element into the stack, so automatically it goes into last. And while you're popping, the first element from the last comes out. And the next data structure is queues. Queues are again implemented using first in and first out principle. The first data to be entered will exit first, and data which enters through the rear end. So NQ operation is to um, input the data, and DQ operation is to remove the front data element. And as you enqueue, rear end keeps on growing. As you dequeue, front end keeps on decreasing. And again, there are various kinds of queues. This is the basic queue. Later on, we studied about circular queues. In circular queues, you don't have the problem of stack overflow uh, mostly, because you can delete it from the front end and you can maximize efficiency. Next, we went through linked lists, single linked lists. Before we went through linked lists, we understood the dynamic memory allocation. That is, while program execution uh, to create new data elements, we used malloc, calloc, realloc, and free. And free is to clear the existing data entry. So we we implemented various syntaxes, and we understood how all these dynamic memory allocations work, because to understand singly linked lists we needed dynamic data allocation. And singly linked lists, structurally it's an array component and a pointer component. The pointer component points towards the next element in the list. So whenever there's an insertion operation in single linked lists, it's always you have to create a new element, structural pointer, and an array, as well, an integer, yeah, character data element, as well as a pointer which points towards the next linked list. So insertion can be done from beginning and the end. Deletion, again, you're removing a data element, so you have to use free function. Um, free and Even deletion can be done from the front and the end. Even insertion can be done in between, and deletion can be done in between, but you have to write extra code lines. Doubly linked lists, very similar to singly linked list, whereas this is a more efficient structure, as the pointer there's a pointer pointing towards the next linked list as well as the previous linked lists. Trees and graphs. Again, there are various kinds of trees: binary trees, complex trees. We mostly learned about binary trees and binary search trees. And binary trees will have maximum two edges, and the topmost data element is a parent. It will have left child and right child. The one without children is called leaf nodes, and the height of the tree is the number of edges from the parent node to the maximum number of edges from the parent node uh, to any leaf node. And lastly, we studied about graphs. And before we end this presentation, to implement whatever we have learned in this course of data structure, we shall execute a problem on data structures. This is a very famous problem called knight in a chessboard. It calculates the number of steps required by a knight to traverse across a chessboard. The minimum number of steps taken by the knight to traverse across the chessboard, the input will be given via user. Thank you, and we shall see the implementation. Considering the chessboard to be a Cartesian plane and taking the initial position of the knight to be 0, 0, and giving the input or the terminating position as 2, 1, we can determine it needs one step to reach this point. And for the next iteration, let us again initialize the starting position of the knight to be the origin and the terminating position to be 3, 3. We can observe the shortest distance required to reach this destination is 2 steps. Next, we follow the same initial position and input 4, 0 to be the terminating position. We determine the number of steps at minimum taken by the knight to reach this distance or this point is 2 steps. Thank you. This is the end of implementation.